Here's a more complex reductio proof using the first strategy that employs multiple provisional assumptions, what I call the reductio variant, short for the reductio variation on arrow in. This strategy is a way to derive conditional statements that is overall lines 2 through 6, resulting in 7, an arrow in step. So it's overall an arrow in strategy, but it uses a reductio to derive the consequent of the conditional we hope to get by arrow in. So lines 3 through 5 result in 6, justified by one of the reductio rules. This is a handy and useful way of approaching complex conditionals. So take a look. We want to get T arrow R, so we assume T, and then we assume the contradictory of our goal, not R, and from those two assumptions plus the single premise, we're able to get a contradiction. Take a look. Line 1 and line 3 together give us not T. 1, 3, arrow out. And that line 4, together with line 2, quickly give us a standard form contradiction. T and not T from 2, 4, and in. And that contradiction completes the reductio. We started at 3 to give us not R by not in. And now we can complete the arrow in that we started, that we assumed T in the hope of deriving not R. We just got that by reductio, so we can now say at line 7, if T is true, R is false, 2 through 6, arrow in. We've made provisional assumptions, so we have to complete an assumption dependence column to be sure that this is a good proof, but that turns out pretty quickly to be clear that it is a good proof. So line 1 depends on itself, 2 depends on itself, and 3 depends on itself. 4 depends on what 1 and 3 depend on. 5 depends on what 2 and 4 depend on. 1, 2, 3. Line 6, justified by not in, depends on whatever 5 depends on except for 3. 1 and 2. And 7 depends, justified by arrow in, depends on whatever 6 depends on except for 2. So line 7 depends on only line 1, the premise, and that establishes that this is a good proof.